American Motors Vehicle Emission Control Systems for Federal Certification, 1974 model year, light-duty vehicles. Sounds very serious, doesn't it? And complicated. Serious it is, but complicated it's not. In this film, the first half of a three-part series on AMC emission controls, we're going to take a good look at this subject of automotive emissions. What are emissions? And why have they become so important? After all, emissions have been around as long as cars. Why all the concern now? Back in the 20s, the only automotive emission most people worried about was carbon monoxide. And they thought carbon monoxide was dangerous only when breathed in a closed garage or other confined area. But that was before the tremendous expansion in the number of cars, trucks, and buses, and before pollution from a number of other sources, including industry and the increased number of gasoline-powered engines, began to seriously affect the quality of air we breathe. As this happened, automotive emissions and their role in the broad and complex problem of air pollution assumed increasing importance for us all. For our purposes, automotive emissions may be divided into two groups. The first group is the heavy particulates, such as those emitted by factories, cars, and other sources. These heavy particulates irritate eyes, but they need not be a major concern to us, because they fall to the ground and are not normally inhaled. Although they are always present in auto emissions, the use of low-lead or no-lead fuel has helped to reduce the heavy particulates emitted by automobiles. The second group, however, is the group we are concerned with. This group consists of hydrocarbon, carbon monoxide, and nitrogen oxide that make up the emissions we call automotive pollutants. Let's look at the hydrocarbons first. Gasoline is nothing more than a mixture of flammable liquid hydrocarbon, often referred to as HC. The term HC is therefore used to indicate a variety of exhaust emissions resulting from unburned gasoline. When gasoline mixed with air in the combustion chamber is ignited by the spark plug, it changes into hot gases and gives off heat and power. With complete combustion under ideal circumstances, these hot gases, water vapor and carbon dioxide, are odorless, tasteless, and harmless. However, combustion is never perfect. In the normal combustion process, two additional gases are formed. They are carbon monoxide, indicated by the symbol CO, and various unburned gasoline products still in the hydrocarbon form called HC. These are two of the three emission pollutants, hydrocarbons or HC and carbon monoxide or CO. The third pollutant doesn't come from gasoline. It comes from the air. Air is approximately 20% oxygen and 80% nitrogen, another harmless gas. Normally, nitrogen is inert or will not burn, and passes through the combustion process unchanged. However, in extremely high combustion chamber temperatures, the nitrogen combines with oxygen to form a variety of other gases called nitrogen oxides, all grouped together under the name NOx or NOx. Here then, for our purpose, is a list of the principal automotive emissions. Water vapor and carbon dioxide are harmless and a natural result of the combustion process. Hydrocarbons, carbon monoxide, and nitrogen oxide, however, are harmful. These emissions may seriously affect the quality of the air we breathe. They are also important in the formation of the substance that has become a byword for impure air: smog. This form of air pollution results from the reaction of certain exhaust gases, nitrogen oxides and hydrocarbons. When these nitrogen oxides and hydrocarbons are exposed to the ultraviolet rays of the sun, they darken and can be seen by the human eye. What we see is called smog, a substance which can irritate the eyes, lungs, and respiratory system. America's smog, however, should not be compared with the more severe London-type smog formed of more poisonous industrial pollutants, which result from burning coal and oil. This type of pollutant, as opposed to the milder automotive smog, can and has been fatal to plant, animal, and human life. Los Angeles, with the world's largest car population and located in a natural basin with mountains on one side and the ocean on the other, was the first city in America to have a serious automotive smog problem. It was because of this smog that California was the first to enact clean air legislation. Not long after, the federal government established a Clean Air Act in 1967, which affected all cars manufactured since that date. The federal law and the associated state laws concerning emissions are rather involved, but the legal obligations of the manufacturer and the dealer service mechanic are quite clear.
The federal law states that it is expressly forbidden for any person to remove or render inoperative any device or element of design installed on or in a motor vehicle or motor vehicle engine in compliance with regulations under this title prior to its sale and delivery to the ultimate purchaser, or for any manufacturer or dealer knowingly to remove or render inoperative any such device or element of design after such sale and delivery to the ultimate purchaser.
To show that they mean it, violators are subject to a $10,000 fine per each emission system rendered inoperative. This law applies to all motor vehicle engines beginning with the 1968 model year. What does this mean to you? First, the intent of this law is to keep all of the original equipment on the engine in operation and properly adjusted. This simply means that you, as the dealer mechanic, may not remove or disable any engine component or device that would reduce the control of emissions, even if it improves car performance in other ways. It also means you may not change specified engine adjustment settings outside the OK ranges as specified by the manufacturer, such as idle mixture and ignition timing, in a manner that reduces the control of emissions. To date, state inspections for checking vehicle emissions are in operation only in California and New Jersey. However, all states will have vehicle emission control procedures in operation by 1975. The federal governments and California's special emission standards for all engines have put tremendous pressure on automotive manufacturers to meet these demands. In response to these demands, AMC engines have been effectively updated to operate well within the federal standards for an extended period of time, if properly serviced. Here is where your skills and your knowledge of American Motors emission control systems are vital in providing AMC owners with engines that operate within AMC specifications. These systems are not complicated or difficult to understand. There are a total of 8 emission control systems, most of which are required on AMC and Jeep vehicles. They are the TCS, Transmission Controlled Spark, the CTO, or Coolant Temperature Override, the EGR, Exhaust Gas Recirculation, the Air Guard, the TAC, Thermostatically Controlled Air Cleaner, the Fuel Tank Vapor Control, PCV, Positive Crankcase Ventilation, and the Electric Assist Choke. Each one of these systems has its own job to do. The TCS, transmission-controlled spark, effectively reduces NOx emissions by lowering the peak combustion chamber temperature and pressure during the power stroke. This is done by cutting off vacuum advance to the distributor in all gears except high with manual transmissions and at approximately 35 miles per hour with automatic transmissions. EGR, exhaust gas recirculation, also reduces NOx formation. This is accomplished by recirculating some exhaust gas back through the engine intake manifold. This dilutes the air-fuel mixture that enters the combustion chamber, resulting in lower temperatures during combustion, which limits the formation of NOx. The next system is the CTO, coolant temperature override. This system improves drivability by providing full distributor vacuum advance during cold engine operation. The air guard system reduces hydrocarbons and carbon monoxide emissions. This is done by a belt-driven air pump which forces fresh air into the engine exhaust ports to continue the burning of the hot, unburned exhaust gases in the exhaust system. This continued burning converts some of the exhaust gases into harmless carbon dioxide and water. The TAC system, it selects either manifold heated air or cooler underhood air to keep the air entering the carburetor at about 115 degrees Fahrenheit. This simulates summer conditions year-round, so the carburetor can be calibrated much leaner to reduce hydrocarbon emissions, improve engine warm-up characteristics, and minimize carburetor icing. The fuel tank vapor control prevents raw fuel vapors, which are hydrocarbons, from entering the atmosphere. Gasoline vapors from the fuel tank are stored in a canister and are later drawn into the intake system when the engine is running. PCV, positive crankcase ventilation, also prevents raw fuel vapors from entering the atmosphere. It draws crankcase vapors and fresh air into the intake system, where they are burned as part of the air-fuel mixture rather than being expelled directly into the atmosphere, contributing to the problem of air pollution. The electric assist choke is used on all 4-barrel carburetors. The purpose is to match the choke operation to engine requirements more quickly. This reduces carbon monoxide emissions during warm-ups. A 7-volt AC power source for this assist is provided by a special terminal on the alternator. TCS, CTO, EGR, air guard, TAC, vapor control, PCV, and the electric assist choke. These are the 8 emission control systems in use on American Motors vehicles. But remember that emission control systems on engines have different vehicle applications. So check the emission control systems and components usage chart in the appropriate TSM and service specifications handbook. In the American Motors Emission Control Laboratory, very expensive and precise test equipment is used to be sure that emissions from AMC vehicles comply with federal and California standards. But at the dealership, you can check emissions with an infrared analyzer. The job of maintaining low emissions and good engine performance is still a matter of engine tune-up, doing the right work with the right equipment. Specifications for dwell, timing, idle mixture, idle speed, and spark plug gap are listed in your TSM and Service Specifications Handbook. These specifications must be followed to provide good startup performance and drivability while keeping emissions within allowable CO limits, as stated on the emission control information sticker found in the engine compartment. When you follow the correct procedures, you won't have any trouble performing emission control services. And when you understand AMC emission control systems, as covered in this and the following films, you should be able to answer questions the owners sometimes ask. For example, owners of cars with emission control systems may ask,
"What about gas mileage? My 1970 gave me good mileage, But my friends all tell me that none of the new cars give as good gas mileage as the older models. How can that be?
That's a reasonable question. We learned part of the answer when we found that high combustion chamber temperatures and pressures increase NOx emission. To reduce these emissions, the combustion chamber peak temperatures and pressures were lowered by the addition of certain emission controls. In the process, some power was lost. The result is that the driver presses harder on the accelerator pedal to get the performance she's accustomed to, therefore uses more fuel. Today's internal combustion engine cannot be tuned both to peak power and minimum emissions at the same time. And by law, emissions control comes first. And when emissions are reduced, a certain amount of power is lost. This may not be easy to explain to customers who are only interested in performance, drivability, and gas mileage, and not in emissions. But it's a fact of life in the automotive service business. To keep American Motors abreast of the latest advances and techniques in emission control, the AMC Emission Control Laboratory uses highly sophisticated equipment as part of an intensive program of testing, research, and development. All automotive engines and vehicles manufactured today must meet the Environmental Protection Agency's 50,000-mile durability test. Hundreds of tests and over 600,000 miles of vehicle operation are behind the certification of 1974 AMC engines. It's all part of the effort to control engine emissions and to make AMC vehicles the finest in America today. And you're the man who keeps these cars and Jeeps operating efficiently, within allowable federal and state limits, and to the satisfaction of the owner. You're the man who stands behind the Buyer Protection Plan, America's foremost automotive service agreement. It takes your expert knowledge to back up this plan and to make it work. Today, at an increasing rate, more and more owners are finding that American Motors has their kind of vehicles. And your knowledge of such subjects as emission control systems make you our kind of mechanic.